Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to study operators and what are operators and what is their utilization. So in our today's section we'll see how actually these are helpful in numerical methods. Before taking start of the operators, there is one important thing you have to understand it first. How actually we define the operators. Suppose in numerical methods, generally, if we are working within an interval, say this is your interval, and we are taking start the moment from the starting point, we call it as x0, and we have to reach to some nearest point, say xn. In order to reach from x0 to xn, we can divide it into these sub-intervals of equal lengths. These intervals may be of different lengths, but we generally divided it in numerical methods of equal lengths. And the first destination will be, if it is x1, in order to move from the location x0 to the next location of x1, we are basically giving this increment to x0. And in numerical methods, the increment is generally represented by the letter h. So here we can write down, in order to move from x0 to the nearest point x1, I have to give an increment of h units to x0 to reach to the nearest point of x1. Similarly, if I want to go to the next location of x2, then I have to give one more increment of h units, and this can be written in the form of x0 plus 2 times h. So this is the general principle of moving from step to step, from interval to interval, in order to obtain or in order to approximate the solutions. So this is the basic principle to learn about the operators. So there are different kinds of operator, and I'll be studying here or discussing here only those which are frequently used in numerical methods. The first operator we are going to take under consideration is named as the shift operator. Shift operator is the first operator which we are going to go through. And the notation for the shift operator is capital E. The shift operator is generally represented by the letter E. Now the definition of this shift operator is whenever we apply this operator over some function, say fx, it shifts the function to the nearest location, say fx plus h. So this is the one-time application of the operator over a function. So it shifts according to the definition to the nearest location of fx plus h. Similarly, if I apply it once again over the same function, it will take the function to the second level, which can be shown by fx plus 2h. On the same pattern, if I give a negative increment or negative application of the shift operator, so the function will be shifted to the back 1 unit. And on the same pattern, if I give an half increment or half the application of the shift operator over the function fx, so it shifts the function fx plus h by 2. Or there can be some other ways through which we can write down according to this bar or this indication how much increment we have to give to the function. So this is your first operator, which is named as the shift operator. You have to keep this definition of the operator in your mind, because we are going to develop the next few more operators, and we are going to create a link in between the shift operator and the other operators which we are going to study. Okay, after knowing about the shift operator, the next operator is named as the next operator is the Forward, let me write down once again. Okay. Forward difference operator. The notation for the forward difference operator is a delta. This is the notation, you already know about it. Now first we define this operator. What is the definition of this operator? So in our the definition of this operator is whenever you apply this operator over a function, say fx is the function, and you are applying the shift forward difference operator, so it takes the function to the next level minus the original function. This is the definition of the forward difference operator. Similarly, if you apply it once again, or we are applying it twicely, so this can be written as delta into delta f of x, and once you apply over the function, it takes the form according to the definition fx plus h minus f of x. And now the outer delta can be distributed inside the bracket, gives you delta fx plus h and minus delta f of x. And here you can see now this delta is being applied over this function as well as over this function. So whenever you apply it over here according to this definition, it takes the form fx plus h minus fx plus h. This is the output after applying the first shift operator. The forward difference operator. Similarly, for this we get minus is there, and we have to place a bracket here. The definition gives you fx plus h minus f of x. So here you can see after applying the forward difference operator over this function as well as over this function, we got this result. Now this can be further simplified if we split the bracket and join the terms. So here we get fx plus h 2h minus fx plus h from here, and minus fx plus h from here gives you minus 2 times fx plus h, and this minus changes the sign of this and gives you fx simple. So this is the output we get, the application of the delta twicely over the function. Similarly, if you increase the order of this operator, accordingly the result will be changed. So this is a brief description of the forward difference operator. Along with it, we are going to develop a relation between the shift operator and the forward difference operator. So the next step is to create a relation in between the forward to the shift operator. In order to create the relation between the shift to the forward, so here if you, I am using the same definition here. From here, if I use the shift operator, we know that we can replace this fx plus h by writing e of fx, because the definition gives you f of x plus h. So I can replace e for the whole function of fx plus h by e of fx, and this f of x will remain as it is. On taking fx as a common factor, the result takes the form fx outside. Now dropping fx on both sides can give you a beautiful result of the form delta is equals to e minus 1. So here you can see we get a relation between the forward to the shift operator, or we can readjust according to your own convenience or according to your own requirement of the question, like that, or some other formations. So this is your second operator, which is named as the forward difference operator. Okay, the next operator is is named as the backward difference operator. And the notation for this operator is another delta